Hello students, in this session we are going to see the introduction about PLC, Programmable Logic Controller. So PLC is a digital electronic device to control machines and process. It is used as a programmable memory to store the instructions and implement functions such as logic, sequencing, timing, counting and arithmetic. It is specifically designed to make programming easy. Programming is primarily concerned with implementing logic and switching operation or working. The inputs and outputs are connected to PLC and the control monitors, and according to the program, the PLC is operated as stored. History: PLC originally designed to replace hardwired relay and timer logic control system. The advantages are it is flexible, easy to use, easy to program, much faster than relay operated system. And specific features are it is rugged and designed to withstand vibration, temperature, humidity and noise. Interfacing is inside the controller. They are easily programmed. PLC in control circuit architecture is it has an external computer. The PLC has communication mode, microprocessor, input mode and output mode. And the output is taken to sent to the actuator and the process, and the feedback from the process is sensed by the sensor and sent to the input module. Basic PLC structure includes it has an address bus and data bus, battery, user program or RAM, CPU, clock signal, system ROM, data ROM and input output units are connected to control bus and data bus. And the program panel has connection between the buffer, optocoupler, latch and driver interface. The central processing unit controls all the processor with frequency 128 MHz. The memory buffers as temporary storage and the system data and RAM for user program. Main components of CPU, the control and process all the information, contains a clock with frequency between 1 and 8 MHz. It determines operating speed of the PLC and also provides timing and synchronization for all the elements. In memory, there are two types of memory, ROM, RAM and temporary buffer. Input-output interface. They provide isolation for signal conditioning, and the input-output channel generally is compatible with PLC, the range of 5 volt, 24 volt, 110 volt and 240 volt, which is shown in the diagram. The optocoupler has signal to the CPU, and the PLC is a protection diode with the voltage divider circuit. The output channel has three ports: relay type output, transistor type and triac type output. In relay type, the need switching of current of few amperes can be used for both AC and DC switching. No need for additional isolation, relatively slow to operate. In transistor type, the output is faster, need opto-isolators and only for DC switching. In triac for AC type, I need opto-isolators and the AC voltage is 240 volt to 1 ampere. Syncing and sourcing operations. When choosing the type of input or output module for PLC, it is very important to have solid understanding of syncing and sourcing. Only applicable to DC load. It is referred to the electronical configurations in the module and field input, and the device produces current when it is on, it is called source current, and the current when it is on is said to be syncing current. While receiving, there are both syncing and sourcing field devices as well as syncing and sourcing input module. The common practice is used to input module in syncing current mode. Syncing and sourcing operations are given in the diagram. The first one is the input module, and the input module output load is taken, and the input device and the input module output load is given. Inputting programs. Writing program. Initially, programs are entered in the input-output unit for a small hand held in the program of PC. They must have an appropriate software package. Transferring to PLC. Once the program is designed on programming device, it is transferred to memory unit of PLC. Working inside the RAM. Program in RAM can be changed by the user. To prevent loss of this program, PLC is provided with small battery. After a program has been developed in RAM, it may be loaded in EPROM chip and so made permanent. The program step and program task is given. It is an instruction for some event to occur, and the specification of the PLC program memory size is often given in terms of number of programs that can be stored. A small PLC can handle 300 to 1000 steps, and program task consists of number of program steps and examine state of switch B, and if A and B are closed, then energize solenoid P. This is the step-by-step program. Forms of PLC: single boards integrated compact PLC and rack mounted modular PLC. Single boards PLC is small programmable controllers which supplied as integral compact package with small power supply. Typically, it has 6, 8, 12, 24 inputs and 4, 8, 16 output. Example MELSECFH3U. For all the sizing and programming controller, separate modules of power supply and processor are used in rack mounted. Example SIMATIC S7300 and 400. Input output processing is the two types. PLC is continuously running through the program and updating it as a result of input signal. Such a loop is called a cycle. Methods of processing: we have continuous updating and mass updating. In continuous updating, the CPU scans the input channel that occur in the program instructions. Each input is examined individually, the delay time for 3 ms. The output is latched so that they retain the status until the next update. And mass output or output copying has 4 phases: read input scan, program execution, diagnose or communicate, and output scan. And it moves from phase 1 to 4 and repeats the cycle. It works in the following sequence: scans the input and copy to the RAM, fetch and decode the execute the program instruction, copying output instruction to the RAM. Once the program is executed, CPU performs diagnostics and communication tasks and updates all the outputs, and they repeat the sequence from phase 1 to phase 4. Input output address is identified for the PLC manufacturer. With large PLC having several racks of input and output, the rack number followed by the number of modules in the rack, and the number is shown in the terminal. Example, Adam Bradley PLC 5 has 012/0 to indicate the input, and rack 01 at module 2 and terminal 03. Ladder programming. The form of programming commonly used in PLC is ladder programming. Each program task is specified as a rung on the ladder. Thus, a rung could specify that the state of switches A and B can be examined, and if both A and B are closed, then solenoid output is energized. A and B are switches in which power rails are connected at both ends, and input output is given in the ladder diagram. The ladder diagram consists of two vertical lines representing the power rails circuits which are connected as horizontal lines. These are the ladder symbols. Input has contacts not closed until input. Input has contacts which are closed until input, and output is given. Serial instruction is given, and output A occurs when input 1 occurs. Output B occurs when input 1 and input 3 occurs. Output C occurs when input 4 and input 5 occurs, and the end of the program. Example for ladder diagram: switching control of solenoid is given, in which X400 is the input, Y430 is the output, which is connected to a switch. The solenoid operates and the PLC is controlled. To energize the solenoid, the normally open start switch connected to the input is activated by being closed. This might be a solenoid valve which opens and allows water to enter a vessel. For temperature control system, the ladder diagram is drawn. X400 is the input and Y430 is the output. Adjusting the set value on the thermistor, and diode is connected to the PLC, and the heating element is connected to a relay. The input goes from low to high when the temperature sensor reaches the set temperature. The output is then go and on to off. The logic functions can be obtained by the combination of switches, and the figures show the ladder diagrams can be written in such combination and OR combinations. A and B solenoid excites A and B in OR circuit, and the output is taken. NOR circuit, NAND circuit, and XOR circuit using ladder diagrams. Logic functions are shown in the diagram. This is an example for switch controlling a solenoid with a truth table, and A, B, C and the inputs, and the output is in the last column. When A, B, C are 0, output will be 0, and if A, B, C any one is 1, the output will be in 0, and if A is 1, output will be 0. If A and C is 1, output will be 1. A and B is 1, output will be 1. If A, B, C are 1, output will be 1. That is, the solenoid will be activated or energized. Shop door system. The shop door will be open and closed for the customer, which is connected to a PLC, and the solenoid will get excited. Input 1 and input 2 and output is taken from the solenoid output. Instruction list. Each horizontal rung on the ladder represents the ladder language, and alternatively the ladder program can be translated into an instruction set and the program panel on the computer. Instructions list consists of series of instructions which are shown in separate lines. Example, LDA, load input A. The mnemonics codes are used by different PLC manufacturers differ, but international standard IEC 1131C has been proposed and is widely used. LD for Mitsubishi Omron MECH is given using a ladder diagram and the operation as shown in the table. Instruction list and logic function is shown for NAND, AND, OR and NOR as shown in the diagram. When two parallel arms are involved, Mitsubishi treats the situation as ORB instruction and OR together parallel the branches as shown in the diagram. Latching an internal relay. The term latching is used for the circuit that is able to hold the output energized and even through input or energizing it ceases. So the output remembers its last state, that is called as latching. Examples for a stop system. It is required for the PLC to control a motor so that when the start signal button is momentarily pressed, the motor starts, and when the stop button is pressed, the motor switches off. Internal relays or the internal auxiliary marker is used to consider as internal relay, which behaves as relays and associated contacts, but in reality they are not actually relays but simulation by software. Internals can be very useful aids in implementation of switching sequence. They are often used in multiple input conditions. Some of the battery pack have used in circuits are ensured to safety for shutdowning the plant for even in power failure. Example for internal array is given for ladder it is shown in the ladder diagram. Use of internal array to reset a latch. When the contact of input 1 is momentarily pressed, the output is energized, and this closes the contacts on the output and causes latching of output. For unlatching, opening of IR relays is needed, that is input 2 is closed and energizes coil of IR. Battery backed internal relay is shown similarly. Thank you.